This is session number 1 of the chapter Polymers. As a point of examination, you are going to get 5 marks in the examination in the question number 37. In this session, I am going to discuss about the fundamental concepts of polymers and what are the different classification of polymers. So let me start with the fundamental concepts of polymers. So first, I will consider in general, let us assume I consider one simple molecule, that is A. Let us assume A is a simple molecule, right? And when this A combines with one more A, that is also simple molecule, and we are going to get A2, let us assume. And here these A's are simple molecules. They used to unite, they will combine, and you are going to get a molecule with 2 A's and 2 units, I can say, and this I call it as a dimer. Mer stands for units. 2 simple units we have in this molecule A2, therefore I call it as dimer. Let us assume this dimer reacts with one more A. Okay, and what you are going to get here? You are going to get A3, and I may call it as a trimer here. So here, what is the main principle occurred? Some simple molecules, they are going to unite. They used to combine, and you are going to get a molecule with the same simple units. And if 2 combines, you are going to get dimers, and if 3 simple molecules combine, you are going to get a trimer. So let us assume I am going to consider one simple molecule and a large number of simple molecule I am going to consider. So in general I can write here A will be the simple molecule and a large number of the simple molecule. So here I can write a small n. So small n stands for n number of the simple molecule A, that is large number of A molecule. Okay, and when large number of the simple molecules combine, and you are going to get a molecule, that is a large molecule, long chain molecule, and I can call it as what actually AN. Okay, so now here I am going to say this will be monomer. Okay, and AN what you are going to get, that will be polymer I am going to call here. So what actually happened, the simple molecules we call it as monomer. So large number of simple molecules, they used to combine, they used to unite, and you are going to get a long chain of molecules. So AN we have long chain of molecule, and that long chain of molecule with the high molecular weight, and that we call it as polymer. Okay, so 2 terms I used here, one is monomer and one more is a polymer. Okay, and here I am going to write what actually the meaning stands for polymers and monomers. So we'll see what are the keywords to be used while defining the polymer. I told you already, polymer is a long chain molecule. Try to know that one. Polymer is a long chain molecule. Why it is long chain molecule? Because they used to combine, the monomer used to combine, and you are going to get a very big molecule, long chain molecule. Okay, and since we have n number of monomers inside the polymer, therefore the molecular weight will be high usually. Okay, molecular weight will be high, and they are formed by the union of monomers or union of simple molecules, I can call it as. The same simple molecules we call it as monomers. So these are the keywords related to polymer, and now you can easily define what actually polymer is. Polymers are long chain molecules of high molecular weight formed by union of large number of simple molecules. Okay, I repeat, polymers are long chain molecules of high molecular weight formed by union of large number of simple molecules. Okay, so that we call it as a polymer. So now we'll see what is actually the name we have for the simple unit, and I told you that one, these simple molecules or the single units what we have, and that we call it as monomers here. So monomers are nothing but the simple molecules. Simple molecules we call it as monomers, and monomers you can define as the simple molecules from which actually the polymer is going to be formed. The combination of these simple molecules, and you are going to get a polymer, and that simple molecule or a single unit what we are going to consider initially, and that we call it as monomer here. And monomer is defined as simple molecules from which the polymer is formed, and that we call it as monomer. And the large molecule what we are going to get from monomer, and we call it as polymer. And now we'll see one more similar term, and I am going to write here polymerization. So we'll see what actually polymerization stands for. Okay, and I told you already, let us assume I have a monomer. So what is monomer? Self-explanatory word, mono, one, mer, simple units. Okay, so simple unit or one simple molecule we have, and if you combine these monomers, okay, and what we are going to get? We are going to get a long chain molecule, and this long chain molecule we call it as a polymer. Okay, so here I am going to convert monomer into polymer, isn't it? And this process here, so the process what we are going to consider, and that process we call it as a polymerization. So polymerization is nothing but the process of converting monomer into polymer, or you can say the process in which polymer is formed from respective monomers, and that process we call it as polymerization. So these are the three fundamental words we should know about that. One is polymer, and one more is monomer, and the third one is polymerization. Okay, and try to know that one. Polymer is formed from monomer actually, and polymer is a long chain molecule, whereas monomer is a single unit or simple molecule you can say, and the process of converting monomer into polymer, and that we call it as a polymerization. So that is the in general, in simple way, how I can explain the meaning of polymer. So now I am going to consider one simple example, and we'll see how to identify monomer and the polymer, and what is the process of converting that. So here I am going to write one example. Okay, so now see, let me consider one simple example. CH2 double bond CH2, carbon carbon double bond we have. This is the first member of alkene, that will be ethene. Okay, so this is ethene, or you can call it as ethylene also. So now I am going to consider this as monomer. This is the simple unit. Okay, and I told you already, if we have only one simple unit, you are not going to get a polymer. So you should have the same simple unit or the single molecule in a large number. Okay, and how to represent that? You should represent in the left hand side, that is a small n. So what is the meaning of that one? N number of ethene we have. In simple language, large number of ethene we have. So when the same ethene molecules, they used to unite or they used to combine, and you are going to get a long chain molecules of high molecular mass, and that we call it as polymer. So how to write that in a correct way? Okay, the polymer I am going to write here, just see. So here I am going to write CH2 single bond CH2, and the left hand side I will draw a bond, and in the right hand side also I am going to draw a bond, and you just place a bracket like this, and subscript or below you should write a n. This is the way how to represent a polymer. Okay, so what is the meaning of that one? See here I extend the bond, and here I extend the bond. What is the meaning of that? The molecule will continue in the left hand side in the same way, and the right hand side in the same way. So this is not the end of the molecule, that will continue. So because of this reason, you need to extend the line here, and you need to extend the line here, and you are supposed to place a bracket like this. Okay, and why you are supposed to place bracket like this? So CH2 single bond CH2 will be the repeating unit in a polymer. See here, this we call it as the repeating unit. So what is the meaning of that one? So if you consider one more, if you consider the right part of that one, the same repeating unit will be here. The same repeating unit will be present in the left hand side also. So the repeating unit always you are supposed to place in the bracket here. And how many repeating units we have here? Since it is a polymer, we have n number of, that is nothing but the large number of this repeating unit we have, and this is the way of representation of a polymer. Okay, so left hand side, right hand side, you should extend the bond little, and you should place the brackets with the subscript n, you should write here. And after drawing the structure of polymer, take care of valency of carbon. Carbon is a tetravalent element here. So actually here I have written CH2 single bond CH2, and try to observe, initially it was carbon double bond carbon, and here it is carbon single bond carbon, and the reason behind that is here there is a bond attached with the carbon, and here is also there is a bond attached with carbon. Therefore carbon carbon double bond is going to be converted to carbon carbon single bond. Unknowingly if you write a double bond here and the valency of carbon would be 5, that is actually wrong according to chemistry. So therefore take care of valencies of the carbon, usually what we do. And ethene is a monomer, okay, and what is the polymer of that? And we call it as a polyethylene. You can call it as a polyethylene, and usually we consider polyethylene, okay. And try to know, this will be the monomer and this is the polymer we are going to write. And I told you already the process what we are converting, and that we call it as polymerization. The process of converting monomer to polymer, we call it as the polymerization. So this is a simple example what I can consider to explain the concepts about monomer, polymerization and polymer. And don't forget that in case of monomer, it is compulsory to write N, that indicates a large number of monomer we have. And here extend the bonds with the bracket and subscript N you need to write. And what kind of polymerization is, usually we write the name of polymerization above the equation, and if you have any condition, and here we are supposed to mention that, and that is how the polymerization takes place. And this is the very simple example what I consider. So this is about the three fundamental terms what we are going to use in case of a polymer. So now we'll see what about the classification of polymers. What about the classification? So how many types of polymers are there? So we'll see one by one. So polymers are classified into different types based on different conditions we have. So now we'll see about the classification. So now let me write that one. Now I am going to talk about classification of polymers. So we don't classify as it is. We have particular condition or particular criteria, from that we are going to classify the polymers. So first let me talk about what are the conditions from which the polymers are classified. So polymers are classified based on source, and polymers are classified based on structure also, and polymers can be classified based on polymerization, and polymers can be classified based on intermolecular force. So these are the four different conditions what we have while classifying the polymers. So we are going to classify the polymers based on the source, availability, origin, from where we are going to get that one. That is about the first type of classification. Second one is about the structure, how actually polymers look, whether it is straight or branched or like that, and from that we are going to classify the polymers. Based on polymerization, in what method the monomers combine you are going to get a polymer, that is synthetic method, and we call it as based on polymerization. Based on the property intermolecular force, what kind of force present in the polymer, so based on that also we are going to classify, and these four are conditions for the classification of polymers. So now we'll discuss one by one. Roman number 1 I am going to write here, and this will be based on source. So now we'll see how we are going to classify the polymers based on source. or you can call it as based on origin, based on availability, the same thing. Okay, so the first type of polymer based on the source is, first one is natural polymers, and the second one is synthetic polymer, and we have one more type, and that third one is semi-synthetic polymer. I am going to write here, the third one is semi-synthetic polymer. So these are the three different types of polymers based on source: natural, synthetic and semi-synthetic. So as the name indicates, the first one is natural polymers. They used to occur in nature, naturally occurring polymer. Usually the source for such naturally occurring polymer will be plants. So therefore they are found in plants. Usually they are found in plants. And the polymers which are naturally occurring, and if they are going to occur in the plants, and such kind of polymers we call it as natural polymers. And some examples I am going to write. Protein is an example for natural polymer. Cellulose is an example for natural polymer. Starch is also an example. So protein, cellulose, starch. Similarly, these are all the examples for polymers, and that belongs to natural polymers here. And I hope you can guess, protein, that is a kind of biomolecule, and that is made up of long chain of amino acids, and amino acids are linked by a bond, we call it as a peptide bond, so that is also a long chain. Similarly, cellulose and starch, all these are carbohydrates actually, and this is how these are going to occur in the nature, and because of that reason, and these are the examples belongs to natural polymers here. The second one is what actually the synthetic polymer, and one can easily guess, synthetic, artificially prepared or man-made polymers, you can say. Man-made polymers, and these we call it as synthetic polymers. And example I am going to consider, polyethylene is an example for that one. So I explained how actually the polyethylene is going to be formed. So polyethylene is the best example for artificially prepared or synthetic polymer. PVC also I can consider, PVC, I hope you can guess, polyvinyl chloride. So PVC, polyethylene, these are man-made polymers, therefore we call it as synthetic polymers. The third one I am going to move here, and the third one we call it as a semi-synthetic. So here, semi-synthetic, that is actually half natural and half artificial, I can say. Okay, and here we call it as, that is derived from plants. These are derived from plants and modified chemically, and that we call it as semi-synthetic polymers. They are supposed to derive from plants, that will be nothing but the naturally occurring, okay, and we need the properties of that polymer has to be changed. So therefore we add some kind of chemicals, so we are going to modify or we are going to change the property of that particular polymer. Therefore they are derived from plants and modified chemically, and such kind of polymers we call it as semi-synthetic. And one example I am going to consider, rayon. Okay, so if you consider a rayon as an example, try to know the origin of rayon, that will be cellulose, or you can say rayon is the derivative of cellulose. So we have to consider cellulose, okay, that is naturally occurring, and we have to modify that cellulose by adding some kind of chemicals here, and modified form of cellulose, and that we call it as rayon. So rayon is nothing but the derivative of cellulose, and rayon is an example for what actually the semi-synthetic polymer. So this is how we are going to classify the polymers based on source or origin or availability, and the types are natural polymers and synthetic polymers, and the third one is a semi-synthetic polymers here. And now after moving with the first condition, that is source, and now I am going to talk about the second criteria, the second condition, how we are going to classify the polymers. So therefore here I am going to write Roman number 2, and that will be based on structure. Based on structure. So how actually polymers is going to look, based on the structure we are going to classify the polymers here. So we'll see one by one how many different classifications are there. So first let me write that one, okay. And first type is linear polymers, and second one is branched polymers. Second one is branched polymers, and the third one is cross-linked. The third one is cross-linked, or one more name we have, we can call it as a network polymer also. So these are the three different types based on structure. Okay, again it is very simple, self-explanatory words we have. In the case of linear polymers, okay, and the polymers are long and straight chain. Okay, so here you are going to observe long straight chain of polymers we are going to observe. So if it is a very just like this, if you consider the long chain like this, okay, it is a long and straight chain polymer, and that kind of polymer we call it as a linear polymer here. And one example I am going to consider, example is HDPE. Okay, so try to know polythene, you can also call it as a PE. So try to know, PE stands for polythene. So HDPE stands for high density polyethylene. Okay, later we are going to know about the reaction and structure. So right now remember, HDPE stands for high density polyethylene, and that is an example for linear because the structure is long and straight. The second one is what actually the branched polymers, and of course we have a linear chain. Okay, so linear chain with the branches we are going to observe. Linear chain with the branches. So here we have a linear chain like this, and these linear chains are joined by some kind of branches. I can show like this. So linear chain we have, and apart from that we are going to see the branch of that one, and that we call it as a branched chain polymers. And the example I am going to write here, the example I am going to write here is LDPE, low density polyethylene. The previous one was high density polyethylene, and this will be what actually the low density polyethylene. And in case of branch, of course we have a linear chain along with some branches we are going to see. The third one is cross-linked or network polymer. In this case, the structure will be three-dimensional structure, and with heavy branches we are going to see. The branches are there, and we are going to see heavy branches. So if there is a three-dimensional structure with heavy branches here, and that kind of a polymer we call it as cross-linked, interlinked as it is, and a network kind of polymer. And one example I am going to consider, the example will be bakelite. So this is how we are going to classify the polymers based on structure. So now based on the structure, I hope you can get, there are three different types. One is linear polymer, second one is branched polymer, and the third one is the cross-linked or network polymer. So that is about the second classification of polymers based on what actually the structure. The third one we'll see what is that, based on polymerization. So let me write that one. The third one will be based on polymerization. Based on polymerization. And now you know what actually the polymerization stands for. The process of converting monomer into polymer, we call it as polymerization, the process or the method. Okay, and here the polymerization can be classified based on the polymerization. The first one will be addition polymers. The first one is addition polymers, and the second one will be condensation polymers. The first one is addition and the second one is condensation polymers, and these are the two different types of polymers based on the condition polymerization. And now we'll see the first one, that will be addition polymers. So now here the first type is addition polymers. So we'll see what actually the addition polymers, and the second one we know that one, that is condensation polymers. Remember, in case of addition polymers, there will be addition of monomers. Here there will be addition of monomers occurs, and one more character of monomer is monomer should contain double or triple bonds. Double or triple bonds. That is the one basic criteria to identify the addition polymers. Of course, there will be addition of monomers, and the nature of monomer should be that may contain a double bond or a triple bond. And try to know here, there is no elimination. There is no elimination of simple molecules like water. Okay, when two monomers are going to combine, in case of addition polymerization, there is no elimination of simple molecules like water, ammonia, etc. So there is no elimination of simple molecule. Usually in most of the cases we are going to see water as the eliminating molecule. So if these three are the keywords while explaining the concept about addition polymers here, and addition polymer, and example I am going to give here, the one example I am going to consider is polyethylene as I discussed, and one more I am going to consider is Buna. Yes, I am going to consider Buna. Yes, here. So these two are the examples that belongs to addition polymers. So addition polymers are defined as the polymers in which there will be addition of monomers of double or triple bonds, and there is no elimination of simple molecules like water, and such polymers we call it as addition polymers, and polyethylene and Buna yes are the examples for that one. So now addition polymers can be further classified into, see here, the addition polymers can be further classified into, the first one is homopolymers. Okay, and the second one will be copolymers. The first one is homopolymers, and the first one is second one is copolymers. So we'll see now what actually homopolymer stands for, and one more type is copolymer stands for. So try to know homopolymers and copolymers belongs to addition polymers only. That is nothing but you may get double or triple bonded monomers, and of course in these two cases there will be no elimination of simple molecules like water. So now actually we'll see what actually homopolymer stands for and what actually copolymer stands for. In case of homopolymers, you are going to get, the same kind of monomers. You are going to get the same kind of monomers, whereas in case of polymers you are going to get two different kind of monomers. Two different kind of monomers you are going to observe. Okay, and what actually the same kind of monomers? In case of homopolymers, if the one monomer will be A and the one more monomer will also be A, whereas in case of a copolymer, if one monomer is A and one more monomer will be B, means two different kind of monomer we have, and in case of homopolymer we have a same kind of monomers. And the example for this I am going to consider that will be polyethylene, and the example for the second one, that is copolymer, I am going to consider Buna yes. And later with the reactions I am going to explain how actually these two belongs to homopolymers and copolymers. So right now you remember polyethylene belongs to homopolymers and Buna yes belongs to what actually the copolymers here. So this is the addition polymers can be classified into two subclasses, that will be homopolymers and one more will be copolymers. The opposite or the second type of addition polymer, and that we call it as condensation polymers. That I am going to write here condensation polymers. So we'll see what actually the condensation polymers stands for. So let me write here. So of course there will be condensation of the monomers. Condensation of a monomer takes place. Later we'll see some reactions here. Condensation of monomers. Whereas in case of addition polymers, the monomers just unite, that will combine. Whereas in case of condensation polymer, the monomers don't just add as it is. there will be condensation reaction. So what is the meaning of that one? Of course, I told you here, in case of addition polymer, there is no elimination of simple molecules like water. Whereas in case of condensation polymer, since condensation reaction takes place, some simple molecule is going to be eliminated. Usually water is going to be eliminated while writing the reaction, and that's why we call it as condensation of monomers. And here one more condition will be bifunctional or trifunctional monomers you are going to observe. Monomers, so try to know that one. So bifunctional, trifunctional monomers we are going to see here. So what is the meaning of bifunctional, trifunctional? Functional groups we know, organic functional groups. Okay, and if you observe any simple molecule, and let me give some example. If you have a bond COH and bond COH, that is carboxylic acid group, so 2 COOH we have in a simple molecule, so that is actually bifunctional. And 3 functional groups we have, and that we call it as a trifunctional here. So if there is a case of bifunctional and trifunctional monomers, and the polymerization or the polymer what we are going to get, that will be condensation polymer. Whereas in case of addition polymer, and the nature of monomer will be either carbon-carbon double bond or carbon-carbon triple bond. So by observing the nature of monomers also, we can get what kind of polymer we are going to get. And the one more key point is, this is a very important one, there is elimination of simple molecules like water. I am going to write here. So there is elimination of simple molecules like water. Water is going to be removed while writing the reaction, and that is the one of the very important property related to condensation polymers here, and that is how we can define the condensation polymers. Now the polymers in which there will be condensation of bifunctional or trifunctional monomers with elimination of simple molecules like water, and that we call it as condensation polymers. And one example I am going to write here, and that one is nylon 6,6. Nylon 6,6. So nylon 6,6 belongs to what actually the condensation polymers. Later we are going to see the structures of all these. So right now you remember the just simple meaning and examples for this. Okay, so that is about the third different classification of polymer, and the criteria is based on polymerization. And now we'll see the last one, that will be Roman number 4, and what is the condition? Based on molecular forces, based on intermolecular forces, you can say here. So Roman number 4 I am going to write, and the condition will be based on molecular force, and you can call it as based on property also. So based on molecular force or property, how we are going to classify the polymers? One by one we will see. The first one I am going to write here, that will be elastomer. The first one will be elastomer, and the second one I am going to write here. The second one will be fiber. Second one is fiber, and the third one is thermoplastic polymers, and the fourth one will be thermosetting polymers. So these are the 4 different types of polymers based on molecular force or property. Of course, the monomers will join. In case of getting polymers, there will be a force of attraction in between the monomers, so that the polymer is going to be formed. So based on that, or based on the property, we are going to classify the polymers into these 4 and try to know the headings. The first one is elastomer, and the second one is fiber, and the third one is thermoplastic, and the last one is thermosetting plastics here. Okay, and we'll see one by one what about the meanings of these. So first one I am going to talk, that is nothing but elastomers. And try to know elastomers, you can call it as rubber also, both are same, elastomers or rubbers. So I told you that one based on molecular force only. In this case there will be weak molecular force. You try to know that one. Weak molecular force will be present. In case of elastomer, the kind of molecular force is weak, and we know that one, the weak molecular force will be van der Waals force. So van der Waals force of attraction, and I hope you remember van der Waals force is the one of the weakest force that can exist here. So the weak molecular force, particularly van der Waals force of attraction, will be present, and in any polymer if you get a weak van der Waals force of attraction, and that will be the class we call it as elastomer here. And as the name indicates, since the molecular force is weak and that exhibits, that is elastic in nature, okay, they can bend with a greater extent, they can stretch with a greater extent, and after releasing the force it can regain its original shape, and that we call it as elasticity, elastic nature here. And example I am going to write here, and one example I am going to write here, that will be neoprene, and you can consider one more, that will be Bunayan, and actually these two are the class belongs to rubber, that is nothing but elastomer. So try to know, in case of elastomer, weak molecular force will be present, and that will be van der Waals force of attraction, and that class we call it as elastomer. Okay, second one I am going to talk now, and the second one will be the fiber. Okay, so we'll see in case of fiber what kind of force of attraction will be present. In case of fiber, strong molecular force will be present. Strong molecular force of attraction will be present, and a strong molecular force of attraction when compared to this elastomer here, and the kind of force of attraction will be hydrogen bonding you are going to observe. So try to know, in case of fiber you are going to get hydrogen bonding. Fiber you can call it as threads also, both are same, okay, threads or fibers. The force of attraction will be hydrogen bonding. I hope you know the chemical bond formed between hydrogen and electronegative element like oxygen, nitrogen, fluorine, and that bond we call it as a hydrogen bonding. So try to know that one, hydrogen bonding is going to be present in case of a fiber, and fiber has a high tensile strength. High tensile strength means it can withstand the greater weight or pressure, you can say. High tensile strength you are going to get in case of fiber, and example I am going to write here, example will be nylon 6 I can consider, and terylene is an example for fiber or a thread. Try to know, strong force of attraction will be present in case of nylon 6 and terylene, therefore that belongs to a class we call it as fiber. Hydrogen bonding will be the molecular force. Try to know about that. And the third one I am going to move, quite important one, thermoplastics here, and the last one will be thermosetting plastics. So first we will see what actually thermoplastic stands for. Thermoplastics are nothing but that softens on heating and that will become hard on cooling, that will become hard on cooling, and that kind of polymer we call it as thermoplastics. Right, know that way. It is quite interesting. If you consider a polymer and if you heat that, and due to course of heat, what actually that plastic will become soft, that substance will become soft, and after cooling that will become hard, and such kind of polymer we call it as thermoplastics. Polymers or substances which softens on heating and hardens on cooling, and that we call it as what actually thermoplastics here. And try to know, thermoplastics are linear polymers. They are linear or slightly branched. They may be linear or slightly branched in that case, linear or slightly branched. And here you can remold that. You can remold that, and you can recycle that also. The thermoplastics can be remolded and recycled, and the kind of a force will be that is intermediate between, the kind of force will be intermediate between, I have written that one, elastomers elastomers, and one more will be what actually fibers. The kind of force what I have written, that is intermediate between elastomers and fibers. Okay, and that is the main point related to thermoplastics here. So try to know, in case of elastomer we have weak force of attraction, van der Waals force. In case of fiber we have strong force of attraction, that will be hydrogen bonding. But if you consider thermoplastic as an example, the force of attraction will be intermediate between elastomer and a fiber. This is the key point you try to know. That is the kind of force present in that one. Okay, and try to know that can be remolded and recycled. Why? As I told you already, if you consider such polymer and if you heat that, that will become soft. And when it attains the softness in nature, we can remold that. Remolding, changing into different shapes, I can say, and you can recycle that also. So because of this nature, softening on heating and hardening on cooling, and that is the particular point that related to thermoplastics here. And I can give example of PVC, polyvinyl chloride, polyethylene, and such kind of examples I can give. And that is about the third one, that is thermoplastics. We'll see the last one, and that will be thermosetting polymers, and that is exactly opposite of that. Okay, so what is the exactly opposite? Thermoplastics, if you heat that one, that will become soft, whereas in case of thermosetting, if you heat the polymer, that will undergo permanent change in the structure. Okay, so on heating, if you heat that, on heating, that will undergo permanent change in the structure. Permanent change in the structure, and that is the class belongs to thermosetting plastics. And here, whereas in case of thermoplastic, linear or slightly branched, and here this is branched. Okay, this will be branched or heavily branched, you can say, or you can say cross-linked also. This will be cross-linked polymer, cross-linked or heavily branched, you can say. And this cannot be, okay, this cannot be remolded or recycled. I am going to write here. Why you cannot remold or recycle that? Because if you heat that one, that will undergo permanent change in the structure, and you cannot change that also. Okay, and the example I am going to write here, the example will be bakelite. Okay, and one more I am going to write melamine. Okay, and these are the examples that belongs to thermosetting plastics here, and that is all about the classification based on molecular force. That will be elastomer and fiber and thermoplastic, and one more will be thermosetting plastics. And this is all about the classification of polymers. Polymers are classified into 4 different conditions we have: based on source, based on structure, based on polymerization, and based on molecular force. Based on source, we have 3 types: natural polymer, synthetic polymer, and semi-synthetic polymer. Based on structure, linear polymer, branched polymer, and cross-linked or network polymer. Based on polymerization, addition polymers and condensation polymers. In addition polymers, we have 2 types: copolymers and homopolymers. Based on molecular forces, we have 4: elastomers, fibers, and thermoplastics and thermosetting plastics, and altogether is nothing but the different classification of polymers. After knowing the different types of polymers, we'll move with what are the different types of polymerization we have. I told that one polymerization is a process of getting polymers from with respect to monomers. We call it as polymerization. And based on the process, how we are going to get the different polymerizations we are going to discuss now. So the heading I am going to write: the types of polymerization. Types of polymerization. And in that first one is addition polymerization. Addition polymerization. One more name we have, we call it as chain growth polymerization. Chain growth polymerization. The second type will be the condensation polymerization. And the concept is same what I explained already. Addition polymers, condensation polymers I explained under the heading called the classification of polymers based on polymerization, and this is addition polymerization and condensation polymerization. Everything will be same, but that was the polymer and this is the polymerization, that is a process. And we know that one, in case of addition polymerization, there will be addition of monomers containing triple or double bonds, and there is no elimination of simple molecules like water, we know that. And two different types also we know. One is homopolymers and one more will be copolymers. Similarly, here the homopolymerization and copolymerization I am going to write here. So the first one will be homopolymerization. And the second one we'll see, and that would be copolymerization. Okay, and now we'll see the examples here. Actually, in the example of homopolymerization, I have given the example of polyethylene. Okay, so we'll write that one, how it is going to be formed. Okay, and here we are going to write the actual reaction or the structure, I can say. In case of homopolymerization, and I am going to write the structure of polyethylene and how it is going to be formed. The monomer of polyethylene will be ethene. So this will be the monomer, isn't it? Okay, ethene. And how many we have? N amount of ethene, large number of ethene. Okay, and that will undergo the polymerization reaction, isn't it? That will undergo polymerization reaction, and what we are going to get? We are going to get a polyethene, CH2, single bond CH2. I told you that one how to write the structure of polymer. Extend the bond left side, right side also. Put the braces or brackets, and subscript you need to write N and check whether you have written the carbon valency right or wrong. Okay, and that is about how we are going to write the reaction, and it is we'll write the names for this one. Okay, so this will be ethene, isn't it? And this will be polyethylene or polyethylene we can call it as, and this is the monomer and this will be the polymer here. So now I am going to say that this is an example for homopolymerization. What is actually homopolymer stands for? Same kind of monomers. How many monomers we have? How many types or how many kinds of monomer we have? Ethene is the only one monomer. N amount of large number of ethene is going to combine and you are going to get a polyethylene. So since the same kind of monomer we have, therefore polyethylene belongs to the kind of polymer we call it as homopolymer, and this process we call it as what actually homopolymerization. The second type is, and I hope you remember the name, and that we call it as copolymers, and the process we call it as copolymerization. Okay, and we'll see how actually the copolymerization we are going to explain. So now just see, in case of copolymerization, I told you already there will be two different kinds of monomers. Okay, so you just try to know about that one. We don't have a single kind of monomer. We have two different kinds of monomers, and the example what I have given, that will be Buna-S. I gave the example of Buna-S here. Okay, and let me consider that Buna-S, Buna-S, Buna hyphen and capital S you need to write. So first we will see how actually the Buna-S is going to be formed and what are the monomers here. Since Buna-S belongs to a category we call it as copolymers, and you should know that here we don't have single kind of monomer. We have two different kind of a monomer. So in this case the Bu, okay, the Bu what we have, and Bu stands for 1,3-butadiene. I am going to write here Bu stands for 1,3-butadiene. That will be the first monomer. Here Bu stands for 1,3-butadiene. Okay, and capital S what we have, that is the one more monomer, and that will be styrene. That will be styrene. So these two are the different monomers what we are going to see. So we'll see the structure of that one. Okay, 1,3-butadiene. But we have, and I need to consider 4 carbons. okay, and ene stands for carbon carbon double bond, diene stands for two carbon carbon double bonds we have, and the position is 1 and 3. If you start from left side, right side, the same thing. 1 I am going to place here double bond, 1 2 3 I am going to place here double bond, 1 3 butadiene, and balance with the hydrogen, okay, so that the carbon should get the tetravalent nature, and this is the structure of 1 3 butadiene, that is one monomer that will combine with one more monomer. What is that actually? Styrene is the one more monomer, and benzene ring, okay, C double bond to C we have, okay, and balance with hydrogen. Here I am going to write H2, and here I am going to write H, and that would be the structure of styrene. So these two are the monomers of Bona-S. Bu stands for 1 3 butadiene, that is the one monomer, and S stands for styrene, that is the one more monomer. Since we have two different kind of monomer, therefore this Bona-S belongs to a kind we call it as copolymers. I told you that one, this is a monomer, we should write n large amount of that, and this is one more monomer, we should write n large amount of that, and this is what actually the addition polymer, okay. So addition polymer we have, and we are going to add that, okay, and how we are going to add that, now just see. And one more term we have in the name, that will be Na, and that Na stands for, Na will be the sodium catalyst, that is sodium catalyst is the condition what we are going to carry out the reaction in the presence of the catalyst, sodium catalyst. So now I am going to join these two, I am going to unite these two. So here we have, just see what actually CH2, I told you already, left side you should extend the bond, okay, and I am going to join these two, and one simple way I can say here, while joining the two monomers in case of polymerization, especially addition polymerization, the double bond is going to be converted to single bond, and single bond is going to be converted to double bond. In simple, if you want to remember how to join that, otherwise if you join that and after checking the valency of carbon, you are going to get the same thing. So double bond I am going to write here single, and CH single bond we have, I am going to write double, and CH double bond we have, I am going to write CH2. This part is over now. So this carbon is going to be linked with this carbon, not with the benzene here. So then, and we are supposed to join with what actually CH, and single bond CH2 we have, and to the second carbon we have a benzene ring, and I am going to draw the benzene ring for that one, and I am going to extend here, okay, and I will place brackets, and I am going to write N here, and that would be the structure of Bona-S. Okay, so try to know how I have written the structure of Bona-S. And remember, Bona-S is an example for copolymers. Means we have two different kind of monomers, and if you know the name, the example, you can write that one, okay. I told you here Bu stands for 1 3 butadiene, the first monomer, Na will be the catalyst, sodium catalyst, and S will be the styrene, and two different kind of monomers they are going to unite, and this is the structure of a polymer. And actually the benzene ring will be either above or below, you can mention that will act as a certain kind of a branch, what I am going to say, and there will be union of all the carbons here. And I told you how to remember, double bond is converted to single bond, and single bond is converted to double bond. Just add that, and after check the valencies of carbon, that is going to satisfy. So that is about, the second one, that will be copolymerization, okay. And one can now easily guess, if we have a single kind of monomer, that will be homopolymerization. If we have a two different kind of monomer, and that will be copolymerization, okay. And one more thing you just try to know, and if you have only the monomers, and if you don't know whether it is addition polymer or condensation polymer, I told you one way how to identify that from. In case of monomer, if we have a carbon carbon double bond or triple bond, that should act with the polymerization and you are going to get a addition polymer. So we have carbon carbon double bond, and here also we are going to get a carbon carbon double bond, means these monomers, from these monomers you are going to get a polymer, and the polymer will be addition polymer here. One more point I told you that one, in case of addition polymers there will be no elimination of simple molecule like water. So just see, in the first one and the second one we have not eliminated any simple molecule, just we added that one, isn't it? So since there is no elimination of simple molecules like water, therefore I can say these two are the examples for addition polymerization, and this is homopolymerization and this is copolymerization. And in the examination usually you will get the very important point is they ask you to write the reaction and these main conditions, and statement is also you are going to write, and while writing the statement you should take care of one thing what I am going to explain here. While writing the statement you should mention what kind of polymerization is that. Okay, and let me explain that one. In case of first one, how I am going to write the statement. Okay, polyethylene is formed by homopolymerization of ethene. That's it. So the statement, I mentioned the polymer name as well as monomer name along with the type of polymerization. Similarly, in case of second one, Buna-S. So try to know, this will be the structure of Buna-S. Okay, so Buna-S is formed by copolymerization of 1,3-butadiene and styrene in the presence of sodium catalyst. I repeat, Buna-S is formed by copolymerization of 1,3-butadiene and styrene in presence of sodium catalyst here. Remember that one, the mentioning the type of polymerization is important one. If you won't mention that, and you are going to lose 1 marks in the examination. Therefore, I am going to highlight this one, what kind of polymerization we have, and you are supposed to mention that one. Okay, so writing the complete structure like this you are going to get 1 mark, and the statement we are going to get the 1 marks. And don't forget to write the large number, that will be n and n in case of monomer, and subscript n, and don't forget to mention the extending bond like this. And that is about the first type, that will be addition polymerization or chain growth polymerization. So now I am going to talk about the second one. The second one will be condensation polymerization. Condensation polymerization, and we have one more name for that one, that we call it as step growth polymerization. You just try to know that one. Chain polymerization is nothing but addition polymerization, and step growth polymerization is nothing but condensation polymerization. And I explained already what are the key terms should be involved in case of condensation polymerization. There will be condensation of monomers. And what kind of monomers? Bifunctional and trifunctional monomers. And there is elimination of simple molecules like water, and that kind of a process we call it as what actually the condensation polymerization. Okay, and the example what I have given you already, that will be nylon 6,6. Okay, you should write in the same manner, nylon -6, 6. So now we'll see how actually we are going to write the structure of nylon 6,6, and later I am going to explain how to how to define or how to write the statement of the condensation reaction, that will be nylon 6,6 here. Okay, so let me explain that one. So the first monomer I am going to write here in case of nylon 6,6. The first monomer will be hexamethylene diamine. First monomer is hexamethylene diamine, and one more monomer is adipic acid, hexamethylene diamine, and the second monomer will be adipic acid. So we'll try to write the structure of this one. Methylene, okay, and I hope you know CH2, we call it as methylene, CH4 methane, CH3 methyl, CH2 methylene, hexamethylene, hexa 6 methylene, hexamethylene, diamine 2 amine. So therefore bond NH2 here and bond NH2 here, hexamethylene diamine. Okay, you can remember like this. And one more is, what is that? Adipic acid. Okay, so in this case you try to know CH2 4 times, methylene group, 4 methylene groups, and here we have a COOH, and in the left side also we have COOH. So these two are the monomers of nylon 66. You try to know that one. The monomers of nylon 66 are, one is hexamethylene diamine and one more is adipic acid. Okay, and I told you already, you need to write N, that is large number of monomers we are going to get. Okay, and that will undergo what actually the condensation polymerization. And now I am going to write the complete structure of a nylon 66, and one point to remember, and this is an example for condensation polymerization. Okay, and try to know what kind of monomers we have. The main condition is the monomer should have bifunctional or trifunctional. NH2 group, NH2 group, two functional groups we have, and here also COOH, two functional groups we have. So you can imagine that, and we may think that from these monomers we are going to get condensation polymers but not addition. Whereas in case of addition, you should have carbon-carbon double bond or carbon-carbon triple bond. Okay, and one more very important thing is, in case of addition polymerization, there will be no elimination of simple molecules like water, whereas in case of condensation there is elimination. Okay, you have to eliminate simple molecule. Okay, and usually, and in this particular case, I am going to eliminate water. So you need to write minus H2O. Okay, and if you have a one hexamethylene diamine and one adipic acid, you are supposed to remove water. So I am going to underline here OH from adipic acid and one hydrogen from this particular group NH. So H2O is going to be eliminated. So while joining these two, you need to remove the H2O part in that case here. Okay, and if you have one unit of this, one unit of this, water is going to be eliminated. Remember that while drawing the polymer structure, left side also it continues and right side also it continues. Okay, so therefore H of this you are supposed to eliminate, and OH of this you are supposed to eliminate. And why you need to eliminate that OH and this H is, I am going to draw a polymer chain. And don't think that only one amount of water is going to be eliminated. Since we have n amount of hexamethylene diamine, large number of adipic acid here, similarly n amount of H2O is going to be eliminated here. So remember this central H2O and left side H and right side OH. So now I am going to join, I am going to write the structure of that one. So how we are going to write? So NH, okay, extend bond, what we have, CH2 6 times. Okay, so just you see, and bond, one H is removed, what I am going to write, only NH. OH is removed, what I am going to write, CO, or I can write OC, the same thing. Okay, and bond, what we have again, CH2 4 times we have, and at the last what we have, CO we have, and you are going to get this, and I am going to place braces, okay, or brackets, and below I am going to write a N here, and check the valences of all these things. And nitrogen has 3 valences, therefore this is going to be balanced. And what is the name of this compound? And that will be nylon 66. And what kind of polymerization this is? Condensation polymerization. You got this? Okay, and here one more thing I will tell you. Here you can write a minus NH2, and if you don't want to write here, and you can write here plus NH2, both are same, you can use any of this, and the statement you try to know that one. Okay, and if you only write that nylon 66 is formed by hexamethylene diamine and adipic acid, you won't get complete marks for that one, because you have not mentioned the kind of polymerization. The correct statement is nylon 66 is formed by condensation polymerization of hexamethylene diamine and adipic acid. Usually high temperature and high pressure is going to be applied here. Okay, or you can write here also what kind of polymerization. Okay, there is no problem that we can write here what is that condensation polymerization, and here also you can write co-polymerization here, and that is actually the structure of nylon 66. Sometimes what happens in the examination, directly they ask write the partial structure of nylon 66. See, write the partial structure of nylon 6,6. If they ask a partial structure, no need to write the complete reaction, only the final partial structure you need to write. And remember that whether it is addition or condensation like this, right? In case of condensation there will be elimination of water, in case of addition there is no elimination of water. In case of condensation, difunctional or bifunctional, trifunctional groups we are going to see. In case of addition polymers, we are going to get carbon-carbon double bond or carbon-carbon triple bond here, and try to know how we are going to write the structure of what actually the nylon 6,6. Okay, and that is all about the different types of polymerization, addition polymerization and condensation polymerization. Okay, and now actually I explain the different classes also. Sometimes in competitive examination what happens, one example I am going to give you. Okay, so that is, if I consider bakelite as an example, okay, and now you should know, knowing the properties, knowing the reaction, one can easily guess. So try to know, bakelite is an example for synthetic polymer, artificially polymer. Bakelite is an example for a cross-linked polymer also, or network polymer also. And bakelite is an example for condensation polymerization also, and bakelite is an example for thermosetting polymers also here. So the types of classification you need to remember, and examples are very important one, and such kind of questions you are going to get in the competitive examination. Similarly, nylon 6,6. Okay, nylon 6,6 is an example for condensation polymers. Nylon 6,6 is an example for fiber. Nylon 6,6 is an example for synthetic polymer. Okay, so this is how you are going to link with the classification of the polymer. And one more point I am going to see here, in the middle we are going to observe NHCO bond, and that NHCO bond we call it as a amide bond or peptide bond. Try to know that one. Nylon 6,6 we have amide bond or peptide bond. That bond is a bond NH bond CO bond it is, and that will be exactly the middle if you write the structure of that one. And that is all about how we are going to write the different types of polymerization. Okay, and I explained structure of polyethylene and bone-ice, and one more will be nylon 6,6. So we studied the fundamental concepts of polymers and different classification of polymers, and lastly we discussed the two different types of polymerization. Thanks for watching.